Okay, in the name of God, I want to solve a problem in heat transfer coefficient. Some important problems we are gonna understand what is going on inside of some metals when it will transfer from one point to another one. So the reference will be heat transfer, 10th edition of heat transfer from J.P. Holman. Okay, let's get started and go to chapter 4. But first let me introduce some chapter of that. First chapter is introduction, second is steady state conduction and one dimension. Third chapter will be a steady state conduction multiple dimension, and 4 is unsteady state conduction. Then let me go to chapter 4. Problem number 74. Okay, this is problem number 74. We want to solve this problem. Let read it with together first. The corner shown in figure P474, this figure, is initially uniform at 200 degrees Celsius. The first temperature of that would be actually 200 degrees Celsius, and then suddenly exposed to convection around the edge. It means this edge has convection here, and H will be 50 watt per meter square degree Celsius, and temperature is 330 degrees Celsius. Then assume the solid has the properties of clay brick. Examine node 1, 2, 3, and 4, these 4 nodes, and determine the maximum time increment which may be used for a transient numerical calculation. Okay. Just let me prepare this page to understand it more. Okay. So I wanna draw the picture of that. Okay, so this is 1, this is point 2, point 3, point 4. Okay, T infinity will be 30 degrees Celsius, and its H is, this is 30. This H is 50 watt per meter square degree Celsius. This distance is 2 centimeters, and this one is 1 centimeters, as you can see in the picture 74. Okay, for solve this problem we should divide each point in half of this element. Okay, This section is 4.1. This section is 4.2, and so on. We have these two sections, 4.3 and 0.4. 0.3 and 0.4. We want to solve this problem in this situation. But from the table we know rho of this material is 2000 kilogram per meter cubic, and its capacity of that is 960 joule per kilogram degree Celsius. Okay, and the conductivity of that is 1.04 watt per meter degree Celsius. Okay, what we should do first for solve this problem, we know that the formula for this problem is delta t, which is time increment, must be smaller or equal than Ci divided by sigma 1 over Rij. And what is C? C equal rho, better say Ci, rho C or Cp delta V. V is volume of element, volume of each element. Cp, as you know, is heat capacity here, and rho is density of the material, each element, which all of the densities and Cp for all of these 4 points are equal, as I wrote it here. Okay, so we should calculate C for 4 points and delta T for 4 points. After we evaluate C, we should put it and substitute it here, and after we actually evaluate resistance, this term is resistance 1 over Rij, we should calculate it for which point. First we want to do that one, and second that one, and third we should put it inside the time increment and choose the best time and maximum limitation for the time in transient calculation. Okay, so let me write this formula here. We should start with this one. Okay, so for 0.1, what do we have here for 0.1? For 0.1, what resistance we have for 0.1, this element? Because this is element of 0.1. First, conductivity, and second, convection. From point 2 to 1 we have conductivity. From left of point 1 we have conductivity 2, the resistance of conductivity. From point 3 to 1 we have conductivity 2, but from the top we don't have any conductivity, any conduction. We have convection here because maybe here is water and T is 30 degrees Celsius and its H is 50 watt per meter square degrees Celsius. Okay, so we should calculate all of these resistance for point 1. Okay, let's get a start. 1 over R 1 to 2. What do we have? 1 to 2 conduction. And what is the formula? K A over delta X, okay, equals K 1.04. What is A? If we assume that in Z direction, if it is X, Y, and this is Z direction, we assume that we have one the unit of actually Z direction, in Z direction. So what is the A? What is the A? What is the A of point 1 to 2? Point 1 to 2. This would be A, the area of the of resistance, which is half of this is 1 centimeters. Half of that would be 0.005 meter. This is in meter, and this is K. This is K, and this is meter. Delta X, distance between point 1 to 2 is 2 centimeters, as I said here. So in meter we should write 0.002 meters. Okay, let me change the color. I think this is not so appropriate for you to see. Then the answer is 0.026. Okay, let me raise this zone and let me just draw a table for all points. 1, 2, 3, and 4. This would be V as volume, Ci 1 over Rij, and this delta T. Okay, I will fill this table the next in some processes. Okay. Okay. So what do we have in from point 1 to 3 are 1, 2, 3. The resistance from 1 to 3 or from point 3 to 1 not different, because these two resistance from these 2 points are equal each other. It would be K A delta Y, 104 multiplied by O2 Y02, because this is A. And what is delta Y? From 1.2, from point 1 to point 3 is 1 centimeters. 001. Okay, the answer would be 2 0.08. Maybe this is finished. It is dead and I can't write with that. So this is 2.08 for R13, okay? But for 0.1 we have R1 infinity, okay? Infinity means the convection, and this is not this formula anymore. I can write with HA, okay? What is H? As we said here, 50 multiplied by A. What is the A of the 0.1 which is in contact with convection? Here, 2 centimeters. 0.002. Sorry, just need 1 point, okay? So the answer will be 1. 2 centimeters. I wrote it in meter, and sorry, this needs just 1, and these two need just 1 0. I made a mistake. I stand corrected. But the answer is true, correct. But these answers are correct. So, and this one would be 1. Okay. So, if I in 0.1 we have 2 resistance from 1 to 2, and from 1 to left point, which we don't have it here. Okay, so we should multiply 2 by this one, 26, plus 1, 2, 3, which is number is 2.08, and from 1 to convection, which is 1. Okay, so the answer would be 3.6. I wrote it here, 3.6. Okay, I should do this. Process for all of other points. Okay, all of other points. If I do it, this process for all of other points, it was for just 0.1, but we have it for 0.2, 0.4, 0.3. Okay, we should do it, but because we don't have any time in here, and I want to make some videos in a short time, because you are not gonna be tired in them. Just I calculated before. For 0.2 it would be 1 over R, I, and J. For 0.2 would be 2.05. For 0.3 it would be 5.2, and for 4 it would be 3.1. Okay. Okay, let me erase these ones. Okay, perfect. Excellent. Okay, let me continue with calculation of V, because V is volume of each element. For 0.1, okay? For 0.1, 2 centimeters in width multiplied by 5 sorry, 5005. Okay, and as I said here, in z direction we have 1 unit. Okay, so the v here will be 0.1. Okay, for point 2, what do we have for element 2 here? What is the volume of that? Half of 2 centimeters will be 1 centimeters multiplied by 0.005 by 1. It is 510 power minus 5. Okay, so let me write them here. Write them here. Double 1 for 2 minus 5, and we know the volume of point 3 is 2 times point 1, so 2 minus 4, 10 with power minus 4, because point number 3, the volume of that is 2 times of point number 1, and point number 4, the volume of that is 2 times of number 2. Okay, so it would be 10 with power minus, this is 5, it would be 4. Okay, so what do I need anymore? C. Okay, as I said before, the formula of C is rho Cp delta V. I will calculate it for these 4 points. Okay, C1, rho is 2000 multiplied by Cp, which is 96, and pay attention to these unit of them. Okay, this is joule, this is kilogram, this is kilogram, and this is meter. Okay, meter square, meter cubic. And delta V, which is, what is delta V for 1? Is 0.001. Okay, for 2. Okay, the answer is for 1. The answer will be 192. For point 2, again this one, because density and heat capacity are similar for all of points. Just this number is different because of the volume of that. Okay, 5 minus 5 would be 96. C4.3, again similar, and multiply by 2 and time 10 with minus power minus 5. It would be 384. And for last point, again these two are similar, and last one is 10 with minus 4. It would be 192. Okay, so let me put these numbers in here in this table. 192, 96 for point 2, 384 for point 3, and 192 for last point. Okay, so we're done so far, but not completely. I should do some other process to finish the solve of these problems, and it will be this one. Okay, as you can see, this is delta T and this is Ci. Okay, Ci here, this is volume, this is resistance that I calculated the first in first stage, and this is answer of this problem. I should find answer of these problems here between these four numbers. Okay, 1, 2, 3, 4. And what was the formula of delta T? As I wrote it before, delta T must be smaller and equal. Smaller or equal, smaller than Ci divided by sigma I over Rij, or equal than that. Okay, so this would be the number. I put it here. Let us calculate it. Okay, for point 1, sorry. Okay, Ci, what is Ci for point 1? 192 divided by 3.6. Okay, 192 divided by 3.6. Okay, what would be the answer? 53.3 seconds. For 2, 96 divided by 205. What is the answer? The answer is 46.8 seconds. For 3, as you can see here, 384 divided by 5.2 will be 73.8 seconds. And last but not least, 4.4. Sorry. Okay. 192. 3.1 in denominator. The answer would be 61.9 seconds. Okay. So I should put them in this table. Let me separate this column. So I can write it here. 53.3 second is 46.8 for third point. The answer will be 73.8, and for last one 61.9. Okay, so which one of these four numbers, which one is smaller than the others? 53, 46, 73, or 61? Definitely this one is smaller than the others. For point 2, for this one. Okay, so the time increment for this point is 46.8 second. So the answer of these problems, okay, let me change the color, is 41.6. Delta T max is 46.8 seconds. The value of delta T shouldn't be more than this value. Okay.